Nikola Tesla was born in 1857 at Smiljan, Lika, a borderland region of Austro-Hungary, of the Serbian race, which has maintained against Turkey in all comers so unceasing a struggle for freedom. His family is an old and representative one among these Switzers of Eastern Europe, and his father was an eloquent clergyman in the Greek Church. An uncle is today metropolitan in Bosnia. His mother was a woman of inherited ingenuity and delighted not only in skillful work of the ordinary household character but in the construction of such mechanical appliances as looms and churns and other machinery required in a rural community. Nikola was educated at Gospic in the public school for 4 years and then spent 3 years in the Real Schule. He was then sent to Karstadt, Croatia, where he continued his studies for 3 years in the higher Real Schule. There for the first time, he saw a steam locomotive. He graduated in 1873, and, surviving an attack of cholera, devoted himself to experimentation, especially in electricity and magnetism. His father would have had him maintain the family tradition by entering the church, but his native genius was too strong, and he was allowed to enter the Polytechnic School at Graz, to finish his studies, and with the object of becoming a professor of mathematics and physics. One of the machines there experimented with was a Gramme dynamo, used as a motor. Despite his instructor's perfect demonstration of the fact that it was impossible to operate a dynamo without commutator or brushes, Mr. Tesla could not be convinced that such accessories were necessary or desirable. He had already seen with quick intuition that a way could be found to dispense with them, and from that time he may be said to have begun work on the ideas that fructified ultimately in his rotating field motors. In the second year of his Graz course, Mr. Tesla gave up the notion of becoming a teacher and took up the engineering curriculum. His studies ended, he returned home in time to see his father die and then went to Prague and Budapest to study languages, with the object of qualifying himself broadly for the practice of the engineering profession. For a short time he served as an assistant in the government telegraph engineering department, and then became associated with M. Puskas, a personal and family friend, and other exploiters of the telephone in Hungary. He made a number of telephonic inventions, but found his opportunities of benefiting by them limited in various ways. To gain a wider field of action, he pushed on to Paris and there secured employment as an electrical engineer with one of the large companies in the new industry of electric lighting. It was during this period, and as early as 1882, that he began serious and continued efforts to embody the rotating field principle in operative apparatus. He was enthusiastic about it, believed it to mark a new departure in the electrical arts, and could think of nothing else. In fact, but for the solicitations of a few friends in commercial circles who urged him to form a company to exploit the invention, Mr. Tesla, then a youth of little worldly experience would have sought an immediate opportunity to publish his ideas, believing them to be worthy of note as a novel and radical advance in electrical theory as well as destined to have a profound influence on all dynamo-electric machinery. At last, he determined that it would be best to try his fortunes in America. In France he had met many Americans, and in contact with them learned the desirability of turning every new idea in electricity to practical use. He learned also of the ready encouragement given in the United States to any inventor who could attain some new and valuable result. The resolution was formed with characteristic quickness, and abandoning all his prospects in Europe, he at once set his face westward. Arrived in the United States, Mr. Tesla took off his coat the day he arrived, at Edison Works. That place had been a goal of his ambition, and one can readily imagine the benefit and stimulus derived from association with Mr. Edison, for whom Mr. Tesla has always had the strongest admiration. It was impossible, however, that, with his own ideas to carry out, and his own inventions to develop, Mr. Tesla could long remain in even the most delightful employ, and, his work now attracting attention, he left the Edison ranks to join a company intended to make and sell an arc lighting system based on some of his inventions in that branch of the art. With unceasing diligence he brought the system to perfection and saw it placed on the market. But the thing which most occupied his time and thoughts, however, all through this period, was his old discovery of the rotating field principle for alternating current work, and the application of it in motors that have now become known the world over. Strong as his convictions on the subject then were, it is a fact that he stood very much alone, for the alternating current had no well-recognized place. Few electrical engineers had ever used it, and the majority were entirely unfamiliar with its value, or even its essential features. Even Mr. Tesla himself did not, until after protracted effort and experimentation, learn how to construct alternating current apparatus of fair efficiency. But that he had accomplished his purpose was shown by the tests of Professor Anthony, made in the of winter 1887-8, when Tesla motors in the hands of that distinguished expert gave an efficiency equal to that of direct current motors. Nothing now stood in the way of the commercial development and introduction of such motors, except that they had to be constructed with a view to operating on the circuits then existing, which in this country were all of the high frequency. The first full publication of his work in this direction outside his patent was a paper read before the American Institute of Electrical Engineers in New York, in May 1888, read at the suggestion of Professor Anthony and the present writer, when he exhibited motors that had been in operation long previous, and with which his belief that brushes and commutators could be dispensed with, was triumphantly proved to be correct. The section of this volume devoted to Mr. Tesla's inventions, the utilization of polyphase currents, will show how thoroughly from the outset he had mastered the fundamental idea and applied it in the greatest variety of ways.